So section 5.2, we learn a third way to solve an equation that has an x squared and an equal sign. There's at least three, there's probably 4 or 5 ways to solve equations that are in the form, they have an x squared and they have an equal. And the methods that we've had so far, in chapter 1, I think it was in section 1.9, we learned how to solve these kinds of equations by factoring. In the last section, we learned how to solve this kind of equation using the C's, or the completing the square. And today, in this section, we're going to learn a third way to solve the problem of the form it has an x squared and it's set equal to 0. And I just want to refresh your memory. Each one of these methods will ultimately produce the same answer. So usually, if I'm asked just generically to solve and I'm not asked to use a specific strategy, I use the strategy that's easiest for me. But let me just show you. So for 2a, I'm going to solve this x squared minus 6x minus 7 equals to 0 using factoring that we did in chapter 1. And I don't need to use grouping factoring when I go to factor. I'm going to make 2 parentheses. There's no common factor to worry about here. And the numbers that I need to throw in these parentheses, it's like the bottom row of my template. One needs to be plus, the other needs to be minus. They need to multiply to negative 7, and they need to subtract to be negative 6. And that's going to be perfectly positive 1 and negative 7. Because if I multiply positive 1 and negative 7, I get negative 7. And if I do 1 minus 7, I get negative 6. So one of my parentheses is going to get a minus 7. The other parentheses is going to get a plus 1. It wouldn't matter which parentheses I put the plus 1 in. Once we solve by factoring, once you have the problem factored, you set each of the parentheses equal to 0, and you isolate the x. Regardless of what strategy I use to solve the problem, I'll get exactly the same answer. There's no need to solve a problem 3 different ways. But just to show you that you can. Factoring is actually the least powerful of these methods. Sometimes factoring doesn't work. If an answer would have an I or a square root in it, factoring, the thing will be prime and factoring won't work. The other 2 methods, the method we did in section 5.1, solving by completing the square, if the answer has an I or a square root, will still give me the answer. So to solve by completing the square, which is what we learned in the bottom of section 5.1, I'm going to use the methods the steps that I created in the last video. The first step to solve by completing the square is to get the number without the letter alone on the right hand side. Sometimes it was done for me, but it's not done here. So step 1, get the number without the letter alone on the right hand side. Adding 7 to both sides. Step 2, add C to both sides. Step 3, change C to a number. Sometimes I don't actually show the step 2, and I just show the number here. But that's technically my step 2. And always C is the number in front of the x to the first power term, divided by 2, and then squared. So C is going to be negative 3 squared, which is positive 9. So the step 2 that says add C to both sides follows step 3, or step 3 follows it. I'm going to add 9 to both sides. Done with step 3. Moving on to step 4, lazy factor the left side, simplify the right side. The left side's always going to factor into one parentheses with a square, and the number right before you squared to find the c goes in that parentheses. So this is going to be x minus 3 quantity squared on the left-hand side. Lazy factor the left side, simplify the right side, and then solve by square root plus or minus square root using the square root property. And the left side becomes x minus 3. The right side, the square root of 16 is 4. And when I'm solving with the square root property, if the right side doesn't have an I or doesn't have a square root, my best answer doesn't have a plus or minus sign. So I shouldn't have a plus or minus sign in my answer. I'm going to add 3 to both sides and get x equals 3 plus or minus 4. Make up the two problems implied by the plus or minus, which is x equals 3 plus 4 and x equals 3 minus 4. The 3 plus 4 is 7. The 3 minus 4 is negative 1. Same problem, so I can't get a different answer. It turns out that solving by completing the square, that this step right here gives me information that I wouldn't get solving by factoring. I'll show you what I mean. Let me see if I could do this here. I'll show you graphically what I mean. I pulled out my graphing calculator, and I'm going to take this function, I'm going to move the 16 over and graph x minus 3 squared minus 16. I'm going to graph this, and this point right here, this graph is called a parabola, and this point right here is the point 3, negative 16. These numbers, if you change the sign of that number, keep the sign of that, it tells me where the graph crosses the x-axis. My other answers, the 7 and negative 1, this 7, the 7 is where the graph, the x-coordinate of the x-intercept, where the graph crosses the x-axis, and the negative 1 is where the other point where it crosses the x-axis. So just for those of you that are visual, if I graphed this function, x squared minus 6x minus 7, I guess I should have just graphed that. That would have made more sense. If I graphed x squared minus 6x minus 7, that would have been better. If I graphed that, it crosses the x-axis at negative 1, it crosses the x-axis at positive 7, and the bend in the parabola is at the point 3, negative 16. So this graph passes through the point negative 1, 0. It passes through the point 7, 0, and it bends at 3, negative 16. Solving the problem by factoring gives you this information with regards to the graph. And this step of solving the problem by completing the square, you can back into that bit of information. So the reason we might use completing the square is if I want to draw a picture, it gives me more detail than solving by factoring. Not such a big deal because completing the square can sometimes be worked around when I'm graphing parabolas, which we're going to do in section 5.3. So that's review of chapter 1, a review of section 5.1, and now the easy stuff, how to solve a problem using the quadratic formula. So the quadratic formula, which I have written up here, the quadratic formula is a tool to solve very specific styles of equations. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And it's used to solve problems that are in this form, and this is almost too generic. A number times x squared plus or possibly minus a number times an x plus or possibly minus a number without a letter, and equal to 0. So if I have, on the left-hand side, if I have three terms, they can be separated by addition or subtraction. The first term is some number times an x squared. The second, or the middle term, is some number times an x to the first power. And, sorry, that's my phone. And the third is a constant, which is a number without a letter. If I get that set up, I can use, I don't know how to hang this phone up. It's a new phone. If this is set up, if we have three terms on the left-hand side, the first being a number times x squared, the sign between the middle, first and the second term, positive or negative, then the second term, a number times x to the first power, and the third term, followed after a plus or a minus sign, a number without a letter, and to the right of the equal sign, 0. If I have those set up, I can solve the problem without using any x's. And very specifically, if I looked at problem 2c and it said solve x squared, which is really 1x squared, minus 6x minus 7 equal to 0, what I'm going to do is I'm going to remove the letters from the problem, and in order, alphabetically, take the numbers and give them letters. The number in front of the square term, I'm going to call A. The number in front of the first power term, along with its sign, I'm going to call B. And the number without the letter, the constant, I'm going to call C.
Wait. Sorry.
Thanks. And then I'm going to take these three numbers and plug them into the formula. And very specifically, I'm going to go x equals, I'm going to make a big fraction, I'm going to have a plus or minus sign and a square root symbol, and the first thing I'm going to put in the numerator is a negative sign from the formula, and then whatever the value of b is, and b is negative 6. I don't like having double negatives without a parenthesis, so I'm going to put the b in a parenthesis. The formula has a plus or minus sign and then a square root symbol, and the first thing I see under the square root symbol is b squared. I'm going to replace the b inside a parentheses with negative 6 and tack on a squared, and then minus, and then 4, and then this means times a times c, so it's going to be minus 4 times 1, and then times c, which is negative 7. So that's just taking the numbers, changing that b to negative 6, changing that b to negative 6, changing that a to 1, changing that c to negative 7. That's the numerator of the fraction. The denominator is 2 times a. I'm going to leave the number 2, and I need to multiply by a. I claim that I can get the answer for what the answers that I got solving in part A and part B using this formula. So let me do some algebra. The double negative 6 in the numerator will turn out to be positive 6. I'm going to lazy figure out what the underside of the square root. Underside my square root, I have negative 6 in a parentheses squared minus 4 parentheses 1 parentheses negative 7. So the underside of the square root, which is that, simplifies to be the number 64. So I'm going to write a 64 in place of that expression under the square root, and the denominator is 2 times 1. I can do the square root of 64 on my calculator if I don't know it. This gives me x equals 6 plus or minus 8 over 2. And the same rules will follow for plus or minus signs. If after the plus or minus sign there's an I or a square root, I don't need two separate answers. I can leave the plus or minus in my answer. If after the plus or minus sign there isn't an I nor a square root, I need to make up the problems implied by the plus or minus sign and get two distinct answers. So the plus or minus sign implies 6 plus 8 over 2. And 6 plus 8 over 2 is 14 over 2, which is 7. 6 minus 8 over 2 is negative 2 over 2, and that's negative 1. So using the quadratic formula and the values a, b, and c that I snuck from the problem, I get x equal to 7 and x equal to negative 1. When I solve the problem using factoring and when I solve the problem using completing the square, I get exactly the same information. So every problem in this section, once we get out of the review part of this, is going to be just to solve using the quadratic formula. The big thing is the quadratic formula doesn't work like if there's an x cubed. It doesn't work if there's an x to the fourth power. Doesn't work if it's not set equal to 0. It doesn't work if there's 3 terms. But if there's specifically 3 terms, the right side is 0. The first term is a number times x squared. It could be a different letter like y squared. The middle term has a plus or minus sign followed by a number times x to the first power. The last term is of the 3 as a number without a letter. If this is the setup, I can use this formula to solve. Getting close to the end of this video, which is really unfortunate. Let's push through. I'll do 3a and 3b with you. So 3a wants me to solve y squared plus 10y equals 5 using completing the square. I can't solve this one using factoring. It doesn't factor its prime because the answer has a square root in it. So first step, get the number without the letter by itself. It's already there. Second step, add c to both sides. So I'm solving by completing the square. Completing the square requires me to get the number without the letter by itself. Then it wants me to add c to both sides. Then I'm going to change c to a number. It's going to be 10 divided by 2 squared, which is going to be 5 squared, which is going to be 25. So I'm going to change the c to a number. I'm going to lazy factor the left-hand side, simplify the right-hand side. Lazy factoring the left-hand side, this would be y plus 5 quantity squared. The right-hand side is going to be 30. And then the last step is to solve by square rooting, plus or minus square rooting. On the left-hand side, I get y plus 5. On the right-hand side, I get plus or minus the square root of 30. And 30 is not a reducible square root. If I did square root of 30 on my awesome calculator, it tells me it doesn't reduce. I'm going to solve for y by minusing 5 from both sides. And I get y equals minus 5 plus or minus the square root of 30. I say this is the best answer if I'm solving with the quadratic formula or completing the square. If my right-hand side has a square root or an I, then best answer has a plus or minus sign. So that's it for solving by completing the square. I'm going to try to jam in solving the same problem by the quadratic formula. If I wanted to do 3b and solve by the quadratic formula, I can't jump straight into the quadratic formula the way the problem's written, because the quadratic formula is opposite the completing the square. The completing the square needs the constant on the right-hand side, the number without the letter, but the quadratic formula needs the right-hand side to be 0. So if I want to use the quadratic formula, I'll just say quad formula. I need to get it set equal to 0. Now I'm going to pluck off the numbers. The number in front of the squared term is the a. The number in front of the first power term is the b. The constant is the c. And again, that formula is negative b plus or minus the square root of b squared minus 4ac over 2a. If b is negative, I put it in a parentheses. If it's positive, I don't put it in a parentheses. So I'm going to do negative b first in the numerator, which is just negative 10, plus or minus b squared. I didn't need a parentheses here, but it's okay to have it. Minus 4 times a, which is 1, times c, which is minus 5, over 2 times a, which is 2 times 1. Under the radical is 10 squared minus 4 times 1 times minus 5. Under the radical is 120. So this is going to give me negative 10 plus or minus the square root of 120. The denominator is 2 times 1, which is 2. I'm going to reduce the square root of 120 to 2 rad 30. I get negative 10 plus or minus 2 rad 30 over 2. And this is really negative 10 over 2 plus or minus 2 square root of 30 over 2. In the first piece, the 10 over 2 reduces to negative 5. After the plus or minus sign, I could cancel these 2's, and I'll be left with no fraction. I'm left with the square root of 30. My video's got a hiccup, but this is the answer. It's exactly the same answer as the quadratic formula. I couldn't factor because this is prime. I'm going to start a part 2 to the video here in a second.